بتاعه ويطلع احسن كونفيجريشن دي. وده بتتكون من 3 لوب. اللوب اللي على الشمال اللي هو السولار، واللي في النص ده اللي هو تانك تخزين الحراره الناتجه من السولار. اللوب اللي في النص اللي تحت ده بتاع الغاز الحيوي، واللوب اللي على اليمين ده بتاع تحليه المياه. كل لوب منهم بيحتاج طبعا عمليه تخزين الحاجه اللي بينتجها، بالاضافه بيحتاج نظام تحكم عشان تتحكم في عمليه الحراره، العمليه الكيماويه او الحراريه اللي بتحصل في السيستم ده. فمثلا من الحاجات اللي هنا اللوب بتاع الغاز الحيوي بيبدا يعمل فيدنج او بيبدا يدخل شحنه من المخلفات لما مستوى الغاز ينقص في تانك التخزين، عشان لو هو دخل كميه شحنه كبيره مره واحده ممكن عمليه التحويل او عمليه انتاج الغاز الحيوي ممكن تقف. هو لازم يبقى في معدل معين بيدخل بيه الكميه بتاعت المخلفات للتانك بتاع الغاز الحيوي.
كل ده اوتوماتيك حسب
كل ده اوتوماتيك
يعني كده هو ما بيتحكمش فيها، هو حاسبها بس.
خلي الدسكشن خلي الدسكشن بعد خلاص.
والوحده بتاعه تحليه المياه اللي في اليمين برضو بيتحكم في كميه المياه اللي هو بيدخلها للممبرين سيستم حسب كميه الحراره المتاحه. لو في حراره كتير بيدخل مياه اكتر عشان نحصل على مياه محلاه اكتر. فكل دي حاجات لازم نتحكم فيها في السيستم بتاعنا عشان نحصل على اعلى كفاءه للتشغيل النظام.
If you want to explain this aspect, that obviously can be a bit more complicated.
No,
to
we don't.
A bypass here. I mean, obviously, for people that works a lot of in solar thermal engineer might say this is a bit mistaken because obviously, if this hot, you can go directly to the boiler and not going to the storage. But okay, this is the simplest to operate.
This is under discussion. Under study. Okay, we build the hot storage.
Yes.
And we make a bypass and see.
Yes.
Operating like that and like
Yes.
in the other machine, and we'll see in the study what we.
Very good. Okay, this I can skip. I just say that when we have this system, we have 2 ways of analyzing, and we consider that the water production is constant. This is the scenario that we assume at the moment. We want to provide 1 meter cubic per day, or 2 meter cubic, 5, 10, whatever. But we assume that the demand of the community will be more or less constant every day, right? Another approach, which is a bit going another direction, is that instead the amount of waste to be treated is constant. So the design, the system would be different if we go in one direction or in the other. We decide the water production is constant and we will feed the digester depending on how much sun there is. So this is the philosophy of the design at the moment. Questionable, maybe, depending or not, but we need to do some simplification. So at the moment we have this approach. Well, design of MD, I will skip that because it is late. Yeah. We consider there are many, just very quickly, obviously this temperature and the flow influence the membrane. We just used paper, experimental paper from the paper, but there are models that they can be implemented. So at the moment we just use some empirical, some experimental data from a paper from a commercial module that are the same module that we will potentially purchase. So if they didn't hook the data on the paper, it could be that in theory they are reliable. translate or continue?
دي داتا لوحده الممبرين اللي احنا هنستخدمها، بتبين التغيير البرودكتيفيتي الانتاجيه بتاعت الميه المحلاه وكميه الطاقه اللي انت محتاجها عشان تنتج الميه دي مع درجه حراره الميه اللي داخل، الميه السخنه اللي داخل.
بس ده مش شغلنا ولا شغل، ده حاجه منشوره واحنا خدناها كعامل للتصميم. اوكي؟ حاجه منشوره واحنا خدناها كعامل.
هو مستخدمها عشان يعمل الموديل بتاعه.
بيستخدمها
كإكسبيرمنتال كورليشن
بالظبط. اوكي. continue.
Design of ID, again, very simple. I just want to stress this because we change the feeding. This is because we will change the feeding of the digester during the year, there will be eventually some periods that we need to produce more gas, so we need to feed more the biogas. We dimension the digester on the period of maximum feeding, not average, because the digester will suffer most when you feed a lot. So you want to ensure that the digester is big enough.
Yeah, go ahead.
Design of solar feed as well. We designed basically for all components, we use some equation, simplified, we put some parameters and we run the model. So that's the idea, no? And then obviously like each model can be made it more complex. It is just some initial results just of the model. Okay, this is for 500 liters. I know that we have also for 1,000, but I have the slide for 500. So, and the constraints is not really an optimization because we said we want maximum an average of 100 kilo day of cattle manure on average. Okay, so the only thing I want to say is that okay, this is the loads on the system. So we have two loads. One is to heat the digester, and one is to run the membrane distillation. So obviously, because we produce constant water during the year, the load on the MD is more or less constant. It's not exactly constant for some aspect of the control, but it's basically, this is what we need, 50 kilowatt hour per day of thermal heat. While to heat the digester, obviously, we will need more heat during the winter, like to be expected, as simple as that. This instead is the share of energy. This is energy demand, this is energy supply. So energy supply, what does it mean? Very simple again, no secrets, nothing difficult. GIA is just biogas production higher during winter. Okay, we need to provide more biogas, and then during summer a bit less, because we have more from the sun. That's it. And this is the idea of very questionable. We accept all debate on that. Feeding of the digester is not a hard science, the digester. So this is just qualitative because it really depends on the characteristic of the feedstock. So it's not thermodynamic physics, but it's just qualitative. So this would be the feeding. So again, we would feed around 200 kilo per day during the winter, but during the summer only 50 kilo of manure. This is questionable because it means why don't you feed? We can feed all the year around 200 kilo if we want, but then this biogas we will need to use it for something else. That's it. Solar fraction, 56% of the energy is provided by the solar, 44% is provided by the biogas. 71% of this energy goes to desalination, and unfortunately 30% is used to heat the digester, right? That's it. And this maybe is the final slide. Initial sizing for the pilot plant is not yet optimized, obviously. No, we have made it just for the pilot plant. So this is just an idea for the pilot plant in order to make different kind of experiment, what I want to say, but it's not optimized like I was saying before. It's not the optimal system that provides water at the lowest cost. It's just a suggestion for the plant based on this. So we have democratic plant, 50-50. 50 to the biogas and 50 to the solar. Everyone is happy. Nobody. Exactly. And that's it. Some results, but these are simple models. I will stop here because Mohammed will show a little bit more about the model. And Mohammed will translate, and then Mohammed will continue. And you can talk in Arabic.
We have a lot of Mohammed here, don't worry. Even in UK too.
Yes.
نشكر